So once again, good morning, good afternoon, or good evening, wherever you are, you find yourself. Good day. So Shegun is my name, and we'll be talking about the vector and scalar. So if I may ask you, what do you know about vector? What is vector and what is scalar? So Shola, can you tell us?
Vector has both magnitude and direction.
Okay.
While scalar has only magnitude but no direction.
Okay. Can you give us an example? Kausara, can you give us an example? Or Shola, can you give us an example of vector?
We have a scalar product.
When I said example of vector. Yes, Kausara, I want to say something.
I was going to say displacement.
Displacement, yes. Displacement is one of the, because displacement has both magnitude and direction. What is again? We have force, we have magnitude, we have acceleration, we have velocity. So these are the example, because they can ask you what are the example of the vector. So these are the example. Then they can also ask you what are the example of scalar quantity. Scalar, you know, it has magnitude. Yes, over to you.
We have distance.
We have distance. What again?
Momentum.
We have mass.
Mass.
You have length. What again do you have?
Momentum.
So I'm listening to you.
Momentum, acceleration.
You have acceleration should be for the
Vector.
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 Yes.
Okay.
So momentum is also a vector. You know that.
Okay, yeah.
So which one is scalar? Scalar is specific heat. When you hear specific heat in physics, you remember. When you have density, these are the scalar. When you have volume, these are the scalar. When you have speed, these are the scalar. Anytime you have calorie, these are the scalar. Then remember, momentum is a vector. When you have energy, energy is also a scalar. Then when you have distance, distance is also a scalar. But anytime you have magnetic field intensity, this we can call this one a vector. So I will not bother you much on the story. You can read from your course material or get other material online, but we will just go to the calculation aspect of it, the analysis. How do we solve some of those problems? When they said I, what do they mean? When they say J, what do they mean? In what direction are they talking about? Let me quickly share my screen so that we can also benefit from there. Can you see my screen now?
Yes, sir.
Okay. So, like I told you from the introduction, we don't need too much here. we have the material to ourselves, or we just continue and we'll be working together.
So if you can bold it a little bit.
If I can go,
Bold it, you enlarge it, you zoom it up.
can you see
No,
it
you want
there?
to zoom it.
Huh?
So that we can see clearly.
You're the one to zoom your screen. Zoom your screen.
Zoom your screen, just enlarge your screen, you will see.
Just enlarge your screen, you see it.
Okay.
Can you see it now?
Yes, I also have it in my materials there.
Oh, okay. Then I may not be able to follow the material the way it is. So, okay, let's continue. Let's proceed. Like we said, we have a vector. Vectors and scalar. Can you see my handwriting now?
Yes, sir.
Okay. Vector and scalar. So in this context, vector and scalar, like I told us earlier on, there are certain things we need to do. So let's write a vector is a quantity having both magnitude and direction. Having both magnitude and direction. Such as remember, I mentioned some things for us the other time. Part of it is velocity,
acceleration,
acceleration,
momentum,
force,
acceleration, force,
magnetic field,
intensity.
Magnetic field intensity, etc. Let me put it that way. So let's look at the scalar. And we now look at scalar component. Scalar. Let me just put it this way. A scalar is also a quantity having magnitude, but no direction. But no direction. Having magnitude but no direction. E.g. So can you tell us?
Distance, mass,
speed,
length, density.
What are the things that I mentioned that are not on your book?
Volume, speed.
Volume, yes, because these are the things they can give us. Volume.
Speed.
We can have speed.
Speed, yes.
Calorie.
etc. Please write it down. etc. Then they can also ask you or, and let me put it this way, and let me just check this one. And any, this is very important, any real number, any real number, any real numbers can also be part of it. So we move on. When you're not talking about component, a component of a vector, component of a vector under the component of a vector, there are certain things we need to know. Any vector A in three dimensions can be represented. Please just mute yourself. Can be represented with initial points. With initial points at the origin of a rectangle. At the origin of rectangular coordinates. Coordinates system. The rectangular coordinates rectangular system. So let's look at this figure. Call this one Z. Y. X. So the one of X, we have a kind of extension here. So at this point, we call this origin 0, and we call this A. Then we call this one A1I. Here we call it A2J. Then here we call it A3K. Are we together now?
Yes, sir.
Okay.
Yes, sir.
So the question is, we're trying to bring out a particular things we normally use, all these coordinates we normally use. Can I move on?
Yes,
Then
sir.
we said, let's A1 comma A2, comma A3 be rectangular coordinates of the terminal point of vector A with initial point at 0. Remember, at initial point at 0 here. We now say that, okay, the vectors A1I, A2J, and A3K are called the rectangular component. The rectangular component vector. You can underline this. The rectangular component vector, or simply component, vector of A. In the X, Y, and Z direction. Respectively. So what we are saying is, in the essence, that the components, the coordinate point of a three-dimensional, the way it forms are from this particular illustration above on the rectangular face, where we have the vector height A1, A2, A3, and you can see their direction that follows immediately. So that's why, and everything starts from the origin 0. But now let's look at the sum of the resultant we are dealing with, because that is what leads us into another analysis. The sum of resultants from the word results please mute yourself. Of A1I, A2J, and A3K. Is the vector A. So that we can write our A as equals to A1I plus A2J plus A3K. Then the magnitude, we move on into that. Before the magnitude, we write the resultant as A equals to magnitude of A is equal to the square root of A1 squared plus A2 squared plus A3 squared. Then our R will now be Xi plus Yj plus Zk. Then when they ask us to calculate the magnitude aspect of it, we have it to be our R to be our absolute value of square root of S squared plus Y squared plus Z squared. So let's look at the example of this. Are we there now?
Yes, sir.
Yes.
Let's look at the example given. Number one, example one. Just mute yourself once you talk. Thank you. Given R1 equals to 3I minus 2J plus K. Then R2 equals 2I minus 4J minus 3K. Then R3 equals minus I plus 2J plus 2K. So the question says, find the magnitude of A, R3, B, R1 plus R2 plus R3, C, 2R1 minus 3R2 minus 5R3. So always remember, for us to solve this problem, there are certain things we need to know. Solution. What is the formula for the magnitude? We have it R equals to 1R, absolute value of R equals to the square root of S squared plus Y squared plus Z squared. You can look for the proof in other materials, but as for this, we only need to apply it here. Then for A, let's start with A. A asks us to do R3, absolute value of R3. So what is absolute value? We have to go to your R1. What is our R1? We have 3I minus 2J plus K. Is that what you have?
Yes, sir.
Yes, sir.
For R1. R2, you have 2I minus 4J minus 3K.
Yes.
Then R3, you have negative minus I.
Plus
So
2J.
let's write it down. To solve them now together, we have it to be minus I plus 2j, then plus 2k. Please mute yourself because of the recording. Thanks. So we have it to be, now, what represents our x? Our x is here, y is here, and z is here. So what we need to do is substitute them into your square root. We have square root of, now when you have minus I, what it means is you have -1, right?
Yes, sir.
-1 squared plus 2 squared plus 2 squared. So at the end of the day, you have square root of 1 plus 4 plus 4. So which is equals to what?
9.
Square root of 9. And the answer is what? 3. So now let's look at the second one, the B. Under the B, you have R1 plus R2 plus R3, right?
Yes, sir.
So let's take our R1 to be, is what? 3I minus 2j plus k plus 2I minus 4j minus 3k plus minus I plus 2j plus 2k. Now, you have to be careful when you are solving something like this. You need to add the component by component. Let component I move to I. Let component j add to j. Let component k add to k. Now, look at what I'm going to do now. Don't just add everything together, but you must follow the component. If you check the R1, you have 3I. You add 3I to another 3, you have the I component to another I component. The second I component is what? Plus 2I. Another one is using its negative, minus I. Put it there. Plus, open the bracket, minus 2j minus 4kj plus 2j. All the j together plus k minus 3k plus 2k. So add all the I together. If you add all the I together, what do you going to have? 4I plus, when you add everything together here, what do you have?
-4.
Minus 4.
Yes.
Minus 4j. Then when you add the other one together, what do you have? What do you have? You have 0. 0k. Because you have to represent that 0, you have to put it there. 0k. Then we can go ahead now and find the absolute value here using this method. So which is 4I minus 4j plus 0k. So we can now find the square root. Square root of it will be 4 all squared plus minus 4 all squared plus 0 squared. At the end of the day, I will have square root of 32. How do we break 32 down? You recall from the sword equation, sword method, you can actually say it's the same thing as 16 multiplied by 32, which is square root of 16 multiplied by square root of 2, which is equals to 4 root 2. Any question?
No, sir.
Are we together now?
Yes, sir.
So you put down 16 multiplied by 3. Square root of 16.
Thank you. So are we together now? Can I proceed? So we can now solve the C. If you solve the C, you have 2R1 minus 3R2 minus 5R3. So it simply means the 2 that is coefficient of R, you use it to open each of the brackets. You multiply them. That is, I can do it this way, 2 in bracket. My R1 is 3I minus 2J plus 2K. Or plus K, rather. Sorry. That's plus K minus 3. You have 2I minus 4J minus 3K. Please mute yourself, Ola, Shola. So I have it to be minus 5 in bracket minus I plus 2J plus 2K plus 2K. Are you getting it? So I can open the bracket with this by saying 2 multiplied by this. I have 6I minus 4J plus 2K. Then minus 6I minus 12J minus 9K.
So can I ask a question?
Quiet.
The minus 3, won't it affect minus 4J?
It will. That's why I just opened the bracket. I didn't bother myself until when you open that bracket, that's when the negative become effective.
Okay, so once the bracket is not opened yet,
yes, you can still maintain it. But once I open the bracket, remember I still maintain what is here. For example, yes. Let me just change the.
I've done it that.
You see,
I want to ask, what about inside the exam? If we have a question like this, can we just do it directly?
Yes. You can do it because I'm explaining to you. That's why I'm taking my time so that everybody can also be on the same page. I don't want to assume that you know it.
Okay, so thank you.
Except if you want me to do that, I can do it. It's easier.
No, please go ahead, sir. Please go ahead, sir.
You said?
I said you should go ahead with your method, sir. Thank you, sir.
Okay. So you can, in the exam, remember, it's a time stuff, which means you need to quickly work hard in order to meet up some other application. So you have taken my marker away now.
Yes, sir.
Let me just look for another one. Okay, I'm back. So here we have, just be careful with the negative, the way you handle it. That's just the issue. Minus 5I plus 10J plus 10K. So, like I told you the other time, take the component by component. If I take the component by component, I will have 6i. But now, this is where the question you are asking the other time comes to play. We need, okay, let's open the brackets. 6i minus 4j plus 2k negative, here you have negative 6i plus 12j plus 9k. This is plus 5i negative 10kj negative 10k. So we can now begin to see all the I can move to the I, 6i minus 6i, then plus 5i. You now use positive here just to gather yourself. Then minus 4j plus 12j minus 10j. So 2k plus 9k minus 10k. So when you add this one together, you have 5i then minus 4. This is minus 2, right?
Minus 2j.
Minus 2j. Then the final answer here is what?
1k. That's k.
That's k plus k.
Plus k.
Is it plus k? Are you sure?
Yes.
This is 9.
Plus 2, making 11. 11 minus 10, 1.
Okay. 1k. So what next do we need to do?
I think the absolute value.
So we need to now go ahead and apply the method. So we now have the method of 2r1 minus 3r2 minus 5r3, which is the same thing as 5i minus 2j plus k. So when you do it very well, you have 5 squared plus negative 2 squared plus 1 squared, square root of 30. Any question, please?
No, sir.
Yes?
No, sir. No question, sir.
Okay. So all these things are relevant when we are solving the problem. But I would like to give you this question to go and solve and get you have to find the scalar, and at that point, they are also the same method of solving these problems.
Sir,
let's look at, yes?
Can we solve that square root of 30 using solve?
But how do you break it down?
No, that's what I'm asking, sir. That is it possible because we used that one as 32 the other time?
Yes, because I can. Okay, what do we multiply that will give us 30? Give us the example.
That would be 5. That would be 3 times 10.
You said?
I said that would be 3 times 10. That would be 3 times 2 times 5.
No, 3 times 10. You cannot find square root of 10. It's not a
That's what I'm
perfect
saying.
square.
That's what I'm saying. I don't think you can break it down.
You can't break it down. That's why I left it
We
that
don't
way.
break it down. Okay, sir. Thank you, sir. So once
So-
you can't break it down, just leave it like this.
Yes, but anyone you can break down,
Okay, sir.
you can go ahead and do that.
All right, sir.
So what if we want to, what if we use a calculator to do it? Can we also leave it like in a decimal form?
Yes, you can just write the correct one and now set which is equals to anybody that want to mark. I think you guys are doing paper one, right?
Yes, pen on paper.
Yes, sir.
So definitely your step matters. And as a mathematician, we might, lecturer will mark steps, not actual final answer. So that's why you have to also double up your step very well so that you can be able to solve some of those problems easily. I hope that is clear.
Yes, sir. Thank you very much, sir.
Okay. So the question says, find scalar A, B, C such that R4 is equals to AR1 plus BR2 plus CR3. So all you need to do is, we know our require, which is our require, the solution here is we have 3i plus 2j plus 5k, which is equals to, what is 3i? What is, R4 is 3i plus 2j plus 5k, right? So I cannot pick my A outside that I'm looking for to multiply the R1, which is 2i minus j plus k plus b so plus b in bracket I plus 3j minus 2k, then plus c in bracket minus 2i plus j minus 3k. Like we did the other time, collate all the I, then collate all the B, or all the J. Remember, we're using the direction to do that. So when you collate all the I, you have 2A plus B minus 2C. Everything multiplied by I, the component, plus minus A plus 3B plus C, everything multiplied by J, then plus A minus 2B minus 3C, everything multiplied by K. So in this case now, we are to solve them, but don't forget, what is I represented here? Look at it. you equate each of the equation to the corresponding coefficient. That is, we have 2a plus b minus 2c equals to 3. I hope you get it.
Yes, sir. Yes, sir.
Because we have 3 high. If it is 4 high, it will be equals to 4. If it is minus 2, it will be equals to minus 2. Then we have minus a plus 3b plus c equals to 2. Then a minus 2b minus 3c equals to 5. So I will advise you to go and solve this one simultaneously. If you solve it very well, you have your a to be equals to 2 minus 2, your b will be equals to 1, and your c will be equals to minus 3. So go and solve it. Solve this simultaneously. Let me see what you get and snap it to me so that I will also cross-check. So we have our R4 to now be equals to, remember your R4 is from here. We call our R4 to be A R1 plus B R2. Then what is the value? The value of A we substitute it, the value of B we substitute it, and the value of C we substitute it. So that is what we are saying we are asked to do. So we have minus 2 R1 plus, since our B is 1 multiplied by R2 is R2, and minus 3 R3. So the factor R4, we can conclude that the factor R4 is said to be linearly dependent on R1, R2, and R3. The factor R4 is linearly dependent on the following. So, any question?
No, that's all for now.
Yes.
The screenshot, where should we, the picture, where should we send it to you, sir?
Let me just stop sharing first. Can I stop sharing now?
Yes, sir.
Okay. So, for those of us on the platform, I told you that the one that I created the other time, you can make use of. You can make use of it. You can make use of the stuff that I created, the WhatsApp.
Okay, sir.
Then, if you don't have the link, I think the link is also there on your platform. Then I will advise you to pick up the link from there. Then I will also discuss with what do they call them now? The IT, that you guys are not getting our email. But I think some other, I don't know whether, did you check very well? Are you sure you're not getting the email?
Like you sent one before we started the class, sir, right?
Yes. Angela, you got one, right?
No, I didn't.
Sir, I didn't get any email. I'm asking, is it the National Open University email or our own personal email?
It's National Open University email.
It's not here.
Sir, I'm having problem to open my own email. I even just came back from my center to complain about it. So they told me I should wait till Monday.
Oh,
I'm actually on my own mail now, and there's no message at all. There's no mail at all. None at all.